Hi guys, we're still looking at chapter 23, the last section, section D, binomial distribution. And this is example 9 I'm going to talk about today. But I also want to talk about this notation. X is distributed binomially with this number of trials n and this probability of success p. Okay, so if we were writing about this, we could say at the beginning of a question, X is distributed binomially. We could write down the number of trials here, and we could write down the probability of success here. This will become important after we finish chapter 24, where we will be dealing with another kind of distribution. Okay, so X is distributed binomially. That means the random variable X, the number of things we are counting, is distributed binomially. Here's example 9. 72% of people in a group are in favor of a certain change. Okay? There's a random sample of 5 people taken. So we're going to sample 5 people out of that entire group. And that sample is taken randomly, not biasedly, randomly. What's the probability that 3 out of those 5 people are in favor of the change? So we're going to talk about how we will do that. What's the probability that at least 3 are in favor of the change? So we'll talk about that. And see the expected number in the sample in favor of the change. Okay, so distributed binomially, that means we could actually write this entire situation out. So let's start first of all. X, in this situation, in this example, X is distributed binomially. The thing that's happening we need to determine. And the thing that we're looking for, probability of success, that thing, is that they are in favor of the change. Okay, so if X is distributed binomially, X is representing number of people in favor of the change. Okay, so important to understand what X is representing always. So it's distributed binomially, so either they're going to be in favor or they're not going to be in favor. And the number of people we're sampling is 5. And the probability of success is 0.72. Okay, so we could do this entire expansion out by looking at the 5th row of Pascal's triangle and then write each of the terms out as they go. If we think of it in that manner, we would be saying, we would be expanding this probability of success, 0.72, plus probability of failure, out of that bracket, plus probability of failure, which is 1 subtract the probability of success, so 0.28 in this case, and to the power of how many trials, we're looking at 5 random people. Okay, so we would expand this all out. The very first term would represent the probability of all 5 people. The second term would represent probability of 4 people. The third term would represent probability of 3 people. So we would take that third term if this was a non-calculator question and then calculate it. Okay. Probability that at least 3 are in favor. So if that's the case, we're going to need the ones that have 3 to the power of 72, 0.72 to the power of 3. Also to the power of 4, also to the power of 5. So 3, 4, and 5, we would have to add all of those up. Okay, so we could do that out. Pascal's triangle. 1, 5, 10, 10, 5, 1. Okay, so remember, put those all out there. 0.72 to the power of 5, this time to the power of 4, power of 3. I'm not going to have enough room here, am I? Move each of these. Power of 2, power of 1, and the one, this was to be a power of 0. Okay, this one power of 0 for 0.28. This one power of 1 for 0.28. Power of 2 for 0.28, power of 3, power of 4 here, and power of 5 here. Okay, so that is the expansion of this situation. So to answer number A, non-calculator question, probably that 3 are in favor, we would take only 3 are in favor. There it is right there, exponent of the probability of success. So that probability would be this answer. Okay. Part B, probability that at least 3 would be this term, 3, and the next term, 4, and the next term. Oh, there's the term 3, there's the term 4, there's the term 5. Okay, so it would be all of those added up. Alternatively, like we have said before, we could take these 2 and take 1, subtract these 2 to get all of these added up as well. Okay, so we could do that non-calculator. We are actually going to do this with a calculator. But first I'm going to talk about C, expected number in the sample. Expected number in the sample, expectation equals N times P in a simple situation, and this is a simple situation. N, number of trials, we're selecting 5 random people. Probability of success, 0.72. So we just multiply that together and get our answer. So 3.6. So the expected number of people out of 5 that would be in favor of this situation would be 3.6. Okay, so let's look at our calculator to look at doing it using a calculator. All right, so calculator, we are going to do these steps. For part A, probability that 3 out of 5 are in favor of the change. Go to your TI Inspire, and the calculator part, press menu, then 5 probability, 5 distributions, and A, binomial PDF. Notice, PDF, probability distribution function. Binomial PDF. Then a pop-up screen appears. Number of trials, N, so we put that in there. Number of trials is 5 people we're randomly selecting. Probability of success, P, 0.72, 72%. And X value, what random variable X are we looking for? Well, in this case, we're looking for 3, so we put 3 here. And then press OK, and it will give us our answer. Okay, I'm gonna flip this around and actually do this with my calculator. So here we go. We're going to say menu, number 5 for probability, number 5 for distributions, A for binomial PDF. We had 5 trials. We had 0.72 probability, and the X we're looking for is 3. Then we press OK, and there is our answer, 0.292626. So rounded to 3 significant digits, 0.293. Okay, 0.293 is our answer here. 0.293. That's the probability that 3 of the 5 are in favor of the change. All right, next part. Part B, probability that at least 3 are in favor. So with your calculator, you can do a range of numbers instead of doing each of them out separately like this and then adding them together. We can do a range of numbers by looking at binomial CDF, C for cumulative. So looking at more than one term and adding those together. So TI Inspire calculator, 5 probability, 5 distributions, B binomial CDF, and then this pop-up screen appears. So let's take a look at that. Here we go. And we say menu. 5 for probability, 5 for distributions, B, or you can scroll down to find it, binomial CDF. Number of trials, yes, we're still looking at 5 trials. Probability of success is still 0.72. The lower bounds, so the smallest number, random variable X we're looking for is 3, because it said at least 3. And the highest we're looking for, the highest it goes is 5 because our sample was 5. And then OK. And 0.862 would be our answer there. 0.862. So our answer down here, 0.862 is the probability that at least 3, so that would be adding together those for 3, 4, and 5. There we have it.